All right, so let's talk a little bit about the commutative property. There are two different commutative properties, remember. The first which looks like this. A plus B equals B plus A. The other version of the commutative property is A times B equals B times A. So essentially what these two properties are saying is when you're adding or multiplying two different values, the order in which you add them does not matter. So if I go ahead and replace the A's and B's with numbers like this, 3 plus 2 equals 2 plus 3. And of course that's true. 3 plus 2, that's 5. 2 plus 3, that's 5. 5 indeed equals 5. For multiplication, let's replace the A with a 7 and replace the B with a 6. 7 times 6, 42. 6 times 7, also 42. So it just shows you the commutative property is a true property. Now it's very easy to see the commutative property with these examples, but there are a couple examples which aren't as easy to see. So those are the ones that I wanted to talk about with you guys. So the first one would look something like this. Let's say that we have 5 plus 3 plus 9 equals 9 plus 5 plus 3. Well, most students would look at this and say, I don't see the commutative property here. What I think this might be is the associative property, simply because they see parentheses. Well, just because you see parentheses does not automatically assume we have the associative property. As a matter of fact, in this example, this is an example of the commutative property, and here's why. This 5 plus 3 is acting as your A. This 9 is acting as your B. And if you look at the other side of the equation, these values, the 5 plus 3 and the 9, have been flip-flopped. So now we have the 9 first, and then we have the 5 plus 3 second. So you can clearly see that this is the commutative property, but what a lot of students get confused about is how can 5 plus 3 represent our A? Well, because 5 plus 3 is sitting inside parentheses, this object is seen as one individual term. Therefore, it can play the role of one of our variables in the commutative property. Let's take a look at another example that often gets students confused as well. What if we had something like this? 2 times 5 plus 4 equals 5 times 2 plus 4. Again, when students see the parentheses, they immediately jump to conclusions and believe it's the associative property. But again, this is not an example of the associative property. This is an example of the commutative property. The commutative property lives inside these parentheses in this particular problem. As you can see, this plus 4 is just an added bonus on both sides of the equation. But the root of it is the stuff that's inside the parentheses in this example. So we have 2 times 5 on the left side, or if I let A represent my 2 and B represent my 5. And on the right side, I have 5 times 2, the flip of that. So my B is first, my A is second. We can clearly see A times B, B times A. Now let's make sure that the stuff on the left does indeed equal the stuff on the right, because it must in order for the commutative property to exist here. 2 times 5, that of course is 10, plus 4 gives us a value of 14 on the left side of the equation. On the right side, 5 times 2 is 10, plus 4, 14 as well. Both sides are equal, commutative property is held. All right, I hope this helps you understand a little bit more about the commutative property. Have a great day.